Hello students, welcome back to the classroom point. In our previous class, we discussed the galvanic cell and its functioning and how much voltage the galvanic cell is going to produce. There also we discussed the electrode reactions of the anode and as well as the cathode. So in today's class, we are going to discuss the cell potential along with the electrode potential and how to calculate the cell potential values. So let's begin the class now. Electrode potential. So let us take a part of the galvanic cell. From there we shall begin the discussion of the electrode potential. So let us take a metal electrode is dipped in its one of the salt aqueous solution. That means let us imagine this is a zinc electrode dipped in the zinc sulfate solution. You can take any metal rod is dipped in its respective metal salt solution. So here whenever a metal rod is dipped in the metal sulfate solution and connected to the another electrode, two processes usually takes place at every metal electrode. Those two processes are, so this metal can lose the electrons. That means whatever the metal atoms are present on the metal rod, they may participate. I am taking the general reaction. So metal may lose the electrons, n number of electrons, and undergo oxidation process. There is a chance of reducing the metallic ions. Whatever the metallic ions are present in the solution, these may gain of the electrons and also deposit as the metal, so that a reduction process can take place. Example reaction we shall take here. See, the zinc metal rod is present. So zinc metal rod, zinc metal atoms may participate in the oxidation process and produce the Zn2 plus ions, leaving 2 electrons on the metal rod. That means whenever zinc metal atom is coming into the solution, so zinc is leaving its 2 electrons on the metal rod and it comes into the solution in the form of the Zn2 plus. That means this process is known as the oxidation process. Now, the metal ions, already here zinc sulfate solution is there, Zn2 plus. Since this rod is having the electrons, it gets the negative sign. So that these positive ions may get attracted to the negative sign, so that they try to get the electrons. So Zn2 plus ions in aqueous form try to gain of the 2 electrons and try to deposit as the zinc metal on the metallic rod. So here the thing is, two opposing processes are taken place. That means one is the oxidation process takes place, at the same time reduction reaction also takes place. When two opposite reactions takes place, so there is one of the process may be the familiar than the other one. That means one process may be more faster or more dominant than the other reaction. In this case, let us imagine that oxidation process is more dominant than the reduction process. That means this zinc metal rod is more predominantly ready to lose the electrons than to gain up the electrons. In such cases, instead of taking the positive ions, it tries to produce the more number of positive ions, so that the solution completely will be filled with the more number of the positive ions. Since more number of positive ions are developed and here negative charge is produced, so because of the opposing charges developed at the interface of the electrode, automatically potential differences arise. So the potential difference that arises between the electrode and electrolyte because of the oxidation reaction is known as the oxidation potential. So in this case, the potential is called as the oxidation potential. So oxidation potential means how we can show the oxidation potential. Potential is always represented by the letter E. Here it is it has the more tendency to lose the electrons and to produce the Zn2 plus ions. That means zinc is converted into Zn2 plus ions more dominantly than Zn2 plus to zinc. That means this reaction is more dominant reaction, so that we can write down the reaction happens at the electrode, that is zinc solid converted into the Zn2 plus in aqueous form. So this is called the electrode potential that happens at this electrode, and this electrode is having the oxidation reaction. That's why it is known as the oxidation potential. Now let us ready to take another metal rod in opposite electrode. Like here I am taking the copper rod, is dipped in the copper sulfate solution. Here also two opposing reactions again takes place. That is, one is copper, whatever the metal is there, copper rod ready to participate in the oxidation process and produce the Cu2 plus ions along with the 2 electrons. This is oxidation process. At the same time, whatever the Cu2 plus ions are present in the solution in the form of the copper sulfate, ready to get reduced by gaining the 2 electrons, so that they are ready to deposit the copper metal. This reaction is known as the reduction reaction. So in this copper rod also two reactions are taken place. One is the oxidation reaction, second one is the reduction reaction. In these two reactions, if reduction reaction is dominant than the oxidation reaction, then the potential difference, see, during the reduction reaction what happens, more Cu2 plus ions start depositing on the copper rod, leaving negative ions. That means the solution finally becomes the rich source of the negative ions, and these negative ions, that means they accumulate over the surface of the copper rod. Why? Because here copper rod is losing the 2 electrons. Since it lost the 2 electrons, it becomes the positive electrode, and after depositing of the Cu2 plus ions on the copper rod, only leaving the sulfate ions, so the solution becomes the rich source of the negative ions. These negative ions are attracted to the positive electrode, and afterwards they accumulate over the surface of the copper rod. And now again potential difference arises between the electrode and electrolyte interface. That potential difference, because of the reduction reaction, it arises. Why? Because of the more reduction reaction happens, more negative ions are left in the solution. That means even though both reactions are happening, if reduction reaction is dominating than the oxidation reaction, due to that, if any potential difference arises, that potential difference is called as the reduction potential. So here E again is the potential. That potential is because of this reduction reaction, so that we can write down that Cu2 plus aqueous form is converting into the Cu in the solid form. This is known as the reduction potential. So from this it is very clear that whenever a metal rod is dipped in its respective metallic salt solution, two opposing reactions takes place. One is oxidation, second one is the reduction. If oxidation reaction is dominant, if any potential difference arises, that is called the oxidation potential. If a reduction reaction is dominant than the oxidation reaction, then during that, if any potential difference arises, that is called the reduction potential. So reduction potential means we show with the reduction reaction. Oxidation potential means we show with the oxidation reaction. And during the measurement of these electrode potentials, if these electrolytic solutions are taken in unit concentration, that means 1 molar of unit concentration, then these electrode potentials are known as the standard electrode potentials, E0. E0 represents the standard electrode potential. So here it is the standard oxidation potential, there it is the standard reduction potential. Now, when these two are connected by a metallic wire, here ammeter is present. You know that going electrons flows from the negative electrode to the positive electrode, so that ammeter tilts towards the copper rod that we discussed in the galvanic cell construction. Afterwards, here salt bridge also present. That was a different concept that we discussed already. Now, here when this zinc rod is connected to the copper rod, that means the negative electrode is connected to the positive electrode. Here one type of potential is developed, there another type of potential is developed. So the potential difference that is present between the cathode and anode is called the cell potential completely. So in this case, due to the difference in potential, electrons start flowing from the higher electron source to the lower electron source. That means electrons movement is shown from the negative electrode to the positive electrode, and the current flows in the opposite direction. Then how to calculate the voltage developed? See here, current is coming from the cathode to the anode, so that a complete voltage E naught cell standard, that means cell potential, E naught cell equals to E naught cathode minus E naught anode. Cell potential is calculated the reduction potential of the cathode minus reduction potential of the anode. Whatever the electrode potential in this case we are taking, by default we have to consider the reduction potentials of both electrodes, cathode as well as the anode. So if E naught value is positive, then cell works. If E naught value is negative, that cell will not work. E naught value never be 0, not equals to 0 even at equilibrium, but E value equals to 0 at equilibrium. Then these are called as the individual electrode potentials of the single electrode. This is called the electromotive force or E naught of the complete cell, how much electricity is produced in a particular cell. Then where E naught cell and E cells depends. See here, a single electrode potential depends on the type of the metal used for the electrode, concentration of the solution, type of the solution, and pressure and temperature conditions. That is electrode potential, which depends on these 4 factors. Whereas E naught cell is an intensive property. E cell or E naught cell is an intensive property. It do not depend on any of these factors. Even if you multiply the entire reactions also, it will not change. Now let us see here how to calculate the E naught cell for this galvanic cell. E naught of Zn2 plus by zinc solid is given as minus 0.76 volts. E naught of Cu2 plus by Cu is given as plus 0.34 volts. Then E naught cell calculation is equals to cathode value minus anode value. Cathode value how much? 0.34 minus of minus 0.76 volts, so that value equals to 1.1 volts. Now in this reaction, if you increase the concentration of these ions or decreasing the concentration of ions, final E naught cell value do not change. That means E naught cell is an intensive property. So cell representation means the notation is always oxidation half cell has to be written first, followed by the reduction half cell. Already in the galvanic cell we have seen that oxidation reaction takes place at anode. So anode reaction is zinc converts into the Zn2 plus 2 electrons, so that this part we can write down as E naught zinc solid by Zn2 plus in aqueous form. And at cathode, Cu2 plus in aqueous form gain ups 2 electrons and gives Cu, and its value is, its electrode potential can be written as Cu2 plus aqueous form by Cu in solid state. Now total cell reaction is 2 electrons cancel out, so that here zinc solid plus Cu2 plus aqueous form giving Zn2 plus aqueous form plus Cu in the solid state. This is the writing of the complete cell reaction. Now, from the cell reaction, how to write down the cell representation means oxidation half cell. Which is the oxidation part? This is the oxidation part. So that here we can write down that zinc solid by Zn2 plus aqueous form separated by double vertical line. Next, reduction half cell. Reduction part is this one. So that we have to write down the Cu2 plus aqueous by Cu in solid state. But whenever writing the cell representation, if any ions are present in the aqueous form, then their concentrations also to be mentioned in the bracket. I am taking the concentrations as 1 molar, so that I am writing the concentrations also 1 molar in nature. So this is the cell representation. This particular vertical line, single vertical line, represents the interface. That means earlier we discussed that zinc metal is dissolving into the solution. Zinc rod is in the solid state, whereas solution in the liquid state. So the reaction happens at the where both of these phases are met. That is called as interface. So since this change is taken place at the interface, so that it is represented. This double vertical line represents the salt bridge. The given electrode potentials are E0 Zn by Zn2 plus is equals to plus 0.76 volts, whereas E0 Cu2 plus by Cu plus 0.34 volts is given. Now they are asking us to find questions. Cell reaction has to be written. Cell representation, third one is finding the E0 cell. So solution, first of all, try to keep both given electrode potentials either in the reduction potential or in the oxidation potential. According to the UPSC convention, we have to keep all the given electrode potentials in the reduction potential only. So by default, wherever standard electrode potentials are mentioned, that is nothing but the standard reduction potentials. So separately reduction potential they don't mention, but standard electrode potential meaning itself is a standard reduction potential. So here some electrode potentials are given. Here this electrode potential is given oxidation potential. This is the reduction reaction. So let us try to convert this oxidation potential into the reduction potential. So how to convert the oxidation potential into the reduction potential? Remember a shortcut that E0 oxidation equals to minus E0 of reduction potential. That means both oxidation potential and reduction potential are in the same magnitude but with opposite sign. If it is 0.76 is the oxidation potential, then its reduction potential is minus 0.76. So let us try to convert this value into the reduction potential. So I am writing the reduction reaction now. Reduction reaction means Zn2 plus aqueous form converting into the zinc solid giving minus 0.76 volts. See, this is the reduction reaction. For a copper electrode, already reduction reaction is given. Cu2 plus aqueous form by Cu is equals to plus 0.34 volts. Now the question arises, how to write down the cell reaction, cell representation in our cell. And before doing all these things, we have to identify which is acting as a cathode, which is acting as an anode. So there is one more shortcut, that higher the reduction potential, acts as cathode. So for this purpose, we have to convert all the given electrode potentials into the reduction potentials. So reduction potential, reduction potential. Now between this one, whichever is the higher value, that is acting as cathode always. So plus 0.34 is a higher value than this one. So this is acting as a cathode, this is acting as an anode. So I can write down that this is a cathode and this is an anode. So at a cathode always reduction reaction takes place. So I'll write down the reaction at a cathode. So cathode means reduction reaction. Reduction reaction means here Cu2 plus aqueous form, gain of 2 electrons, convert into the Cu. Anode oxidation reaction at anode. Oxidation reaction means zinc solid converting into the Zn2 plus aqueous form plus 2 electrons. Remember that here we have taken the reduction value, but it doesn't mean you should not consider the same reaction while writing the anode. We are converting the given values into the reduction potentials, but the same reaction not necessary to take there, because anode oxidation reaction takes place. Oxidation means zinc to Zn2 plus. So by cancelling these two, so we get zinc solid plus Cu2 plus gives Zn2 plus Cu solid. Cell reaction is written. So this is a cell reaction that happens in the both electrodes. Total cell reaction. Then how to represent this cell? Cell means oxidation half cell first, reduction half cell first. Oxidation half cell. Oxidation half cell means anode reaction. Anode reaction, oxidation half cell is zinc by Zn2 plus, whereas copper rod reduction Cu2 plus by Cu. So that cell representation now. Which is the oxidation reaction? This is the oxidation reaction that is taken place at anode. Zinc by Zn2 plus, Cu2 plus by Cu. Better to mention their physical states along with the concentrations. Here concentrations are to be mentioned. Cell representation is done. Then how to calculate the E0 cell? E0 cell equals to E0 cathode minus E0 anode. Means reduction potentials of both the cathode and anode. Reduction potential of cathode is plus 0.34 volts. Minus of minus 0.76 volts. So total value equals to 1.1 volts. That means this cell functions. Why? Because the total value is equals to positive. Now let us take another question. The given electrode potentials are E0, Zn2 plus by zinc was given as minus 0.76 volts. E0 Cu2 plus by Cu is given as plus 0.34 volts. And E0 Ag plus by Ag is given as plus 0.8 volts. So these are the three reactions. Now they are asking us to find out the possible cell reactions. So that let us see here. Find possible cell reactions. Second one, E0 cell. Third one, cell representation. All these we need to calculate. So let us take the first combination. First combination is, let us take these two. So let us make A, B and C. So from both A and B. So first of all, check whether the given values are reduction potentials or oxidation potential. These are all reduction potentials only. So I am selecting both of these. Between these two, higher the reduction potential acts as the cathode, lower the reduction potential acts as the anode. So automatically cathode means cathode reduction reaction takes place. Cu2 plus converts into the Cu. Anode means oxidation reaction takes place. Zinc converts into the Zn2 plus. This is a cell reaction. Then Cell representation. Cell representation means oxidation part first, reduction part later. So what is the oxidation part? Zinc by Zn2 plus is the oxidation part. Next, Cu2 plus by Cu is the reduction part. Next, so cell reaction is over, cell representation is over. Now let us see E0 cell. Cathode value minus anode value. So 0.34 minus of minus 0.76, that means you are getting the 1.1 volts. So whenever you select both of these, this is acting as a cathode, this is acting as an anode. Now let us select B and C. From B and C, higher the reduction potential, this is acting as a cathode, this one should act as anode. That means in these combinations, copper electrode can act as both cathode in this case and anode in this case. Always silver electrode acts as a cathode, always zinc electrode acts as anode. So now reduction reaction, that is 2 Ag plus 2 electrons gives 2 Ag. Oxidation reaction copper to Cu2 plus 2 electrons. So reaction over 2 Ag plus Cu giving Cu2 plus 2 Ag. This is a cell reaction. Now cell representation. So during the representing this cell, oxidation reaction first. Which is the oxidation reaction? Copper is converting into the Cu2 plus. Silver is converting into the double vertical line. Ag plus converts into the Ag. Here in this stoichiometric equation, 2 are there, but here we take only 1. Stoichiometric coefficients we don't take in the while representing the cell representation. Next, E0 cell for this. Cathode minus anode. Cathode value is 0.8 minus of plus 0.34. So could be equals to plus 0.46 volts. Next, third combination. So I am selecting now A and C from both A and C. So between A and C, higher the reduction potential is with silver and lower is with zinc. So this is cathode, this is anode. Cathode reaction means 2 Ag plus giving 2 Ag. Reduction reaction. I am not writing the electrons now. Why? Because anyhow electrons will cancel out. The purpose of using 2 is zinc is carrying the 2 plus charges. So silver also should have the 2 plus charges. And zinc is participating, zinc is an anode, so that it participates in the oxidation reaction. Zinc gives the Zn2 plus ions. So this is the cell reaction. Then how to write down the cell representation? Oxidation part first. Zinc by Zn2 plus and reduction reaction Ag plus by Ag. Cell representation is over. Then E0 cell. E0 cell is nothing but the E0 cathode minus E0 anode. E0 cathode. Cathode is 0.8 minus of minus 0.76. So this is equals to 1.56 volts. So from this, without solving entire thing, if they ask which one is having the highest E0 cell, so E0 cell is nothing but the E0 cathode minus E0 anode. Higher the cathode value, lower the anode value, higher will be the E0 cell, so that more potential will be generated. Now you can see that in these two cases, it is just 0.34 and 0.76 minus 0.76, value is 1.1. And in these two cases, difference is very less. Why? Because both are positive values. That's why the E0 cell value is less. In these two cases, higher positive value, lower negative value. That's why here we got the highest E0 cell value. So higher the E0 cell value is observed only when the electrodes are having the cathode should have the highest standard reduction potential value and anode must have the lowest reduction potential value, so that when the gap is higher, then E0 cell value gradually increases. So in these reactions, What happens if any of this particular reaction, for example, if I take this reaction and divide by the 2, will it affect the C0 cell value? No. Or else I am multiplying this reaction by 2. It will not affect the E0 cell value. Means any of the cell reactions, whether you multiply or divide, E0 cell values do not change. That's why E0 cell value is known as it is intensive property. It is independent on the stoichiometric coefficients of the cell reactions. So dear students, I hope you understand this class. We shall meet in the next class. Thank you.